afternoon. So this is theory of errors and adjustment again. So we're going to continue the discussion of the theory of errors, error propagation. So this topic is we're going to discuss in this presentation what is an error propagation. So but before we discuss this new topic, we have here a short review of the topics that we are discussed on the past videos. Have here. We discussed the following. So we discussed what is accuracy and how close we are on the target, the precision, the refinement of our individual observation. We have here the most probable value and the standard deviation and the standard error, which have also discussed what is a variance, that is the square of your standard deviation. The standard deviation and or the error of the means, what are the use of the standard deviation? The most probable error, or this is your E50. So all these topics we discuss, we create a histogram and analyzing the data. So ano ba yung mga data that falls within the limits of the accuracy? Another, we have the percent error, which is the E50. So si E50, gagamitin natin if our data accepted on the 50% limit. We have also E90 and E95, which can be used in determining the precision of a certain data. We have also E99.7, which in this type of percent error, we can determine kung ano yung data na pwede natin i-reject para ma-lessen yung error ng ating measurement. Maski pa tanggalan natin siya ng mga blunders and mistake, random errors will always occur. So we can use this error, the standard deviation, to determine the amount kung ano yung data na pwede natin gamitin and anong data na pwede natin i-reject. So we can use the E99.7 in doing so. So we can identify what among 20 measurement, which data na nakuha is a mistake or a blunder. So we can use E99.7. So I have here next, this is also a review. So the standard deviation, so the definition is a comparison of our individual readings or observation to the mean of the reading. So yung mean natin, how far we are from in each individual, gano'n siya kalayo from the mean of the reading or yung ating MPV. We also discussed the standard deviation of the mean. So this is an uncertainty statement regarding the mean and not on the randomly selected individual reading. So since the individual measurements that make up the mean have error, yung individual measurement natin from 1 to 10, so those 10 measurements so have an error, which means yung ating mean also has an error. So the standard deviation of the mean is the positive-negative range. So 50% range, which is positive, 50% range, which is negative, within which the mean falls when compared to the true value. Okay, so I have here in the start with the error propagation. So the topic objective of error propagation, we're going to define first, we are going to define what is an error propagation. We're going to compute error of computed quantities in various surveying works. For example, if we're going to compute the area, so if we're dealing with the area, we multiply two quantities, for example, the length and the width. So pag irregular naman yung polygon or irregular yung area, we determine the angles and we determine also the distance of a parcel. So what if upon determining the angles using our instrument and upon determining the distance, we obtain an error, which means upon the end of the at the end of the survey works, we compute the area of the parcel, so which means yung ating area magkakaroon din siya ng error. So we are going to verify whether the survey works are acceptable or not based yung ating mga standard specifications. So based on the error na ating ma-determine using the mathematical computation, we can identify kung yung ating survey is falls within the standard limit na pwedeng i-accept when it comes to the approval of our plans. Okay? So let's start. So, the calculation of quantities such as yung ating mga area, volume, yung mga differences in height, upon leveling, horizontal distances, angle measurement, and etc. So, using the measured quantities, distance and angle, yung makukuha natin, di ba? Usually, pag nagsasurvey tayo, yung ating nakukuha is distance, angle, and elevation. Ito yung mga raw data na nakuha natin in the field. So, yung ating makukuha nga second quantity, such as yung ating mga area, volume, difference in height, this is done through a mathematical relationship. For example, yung ating uh, latitude and departure of the line. So, hindi tayo makako-compute ng departure and latitude of the line without the angle and the distance. Diba? If the angle and the distance has an error, if we're going to compute now the latitude and the departure of the line, syempre magkakaroon din siya ng error. So, this is done through a mathematical relationship between the computed quantities and the measured quantities. For example, meron tayong rectangular lot. So, yung ating nasa survey is a regular rectangular lot. So, which means yung ating nakukuhang raw data on the field is the distance. So, distance ng length and the distance of the width. So, however, yung ating nakukuhang distance, so it's impossible na wala siyang error, which means yung ating distance na length and the width of the rectangular parcel is may error, then yung ating makukuhang area is magkakaroon din siya ng error. Okay? So this is the concept of the error propagation. So since yung ating na-measured na quantities have errors, it is inevitable that the quantities computed from them will not have errors. Imposible hindi siya magkakaroon ng error. Yung ating mga area, volume, difference in elevation, horizontal distances, and the angle. Evaluation of this error in the computed quantities as the function of the error, this is the function of the errors in the measurement is called the error propagation. Again, the evaluation of the error in the computed quantities, yung ating na-compute na ng mga quantities, is as the function of the error in the measurement. Ito yung tinatawag na error propagation. So, yung may length, the length and the width is my error. If we're going to compute the area, yung area natin is magkakaroon din siya ng error. So, yung tawag doon is error propagation. So, nag-propagate yung ating area as long as we use a measured quantities which is erroneous. So, yung ating computed quantities also, magkakaroon din siya ng error. Okay? So, by definition, we have here the definition of the error propagation. Okay, so this is defined as the process of evaluating the error. Yung ating in-evaluate ay yung error in computed quantities. Again, in computed quantities as a function of the error in the measurement or known error from previous computation. So, it's a function ng error which is yung error na kukuha natin upon measurement. So, this is a way of combining two or more random errors together to get a third. So, yung ating length, yung example natin kanina, if the length is my error, the width is my error, so yung magiging area natin is the third one, which is the area, magkakaroon din siya ng error. So, it also used to combine several independent sources of random error or the same measurement. So, yung gamit ni error propagation is to determine na the error attained. For example, tinanggalan na siya ng mga mistakes, tinanggalan na siya ng mga large error, random error will always occur. So, it is used to combine na several na mga independent sources of random error on the same measurement. Okay? So, these are sample scenario. For example, angle and distance. So, if we're going to determine the coordinate of a point, diba? Yung ginagamit natin usually is the angle and the distance. So, pag nagkukuha tayo ng angle, hindi natin it is inevitable na pag-determine natin ng angle, wala siyang error. And also the distance. So, yung makukompute natin coordinates ng line o other line, magkakaroon din siya ng random errors. For the coordinates, diba? Meron tayong method of determining the area using the coordinate. coordinate method. So, if those coordinates have an error, so yung makukompute natin na area is meron din siyang error. So, the backside and the foreside, di ba? Pag nag-determine tayo ng elevation ng between two places or two different points, yung nakukuha na natin sa leveling is the backside and the foreside. So, upon taking the backside, meron tayong error. At then, upon taking the foresight, meron din tayong error. Therefore, after the survey, yung makukuha nating elevation, meron din siyang error. Okay? So, I hope this scenario are clear to you. So, this is the error propagation will let A, B, C, and so on are the observed quantities which is independent. Ito yung ating mga length and the width, for example, na na-observe na quantities. The distance in the angle, those are example of the independent. Yung na-observe natin on the field. So we have also here E sub A, that is the error attained in measuring the A. Meron tayong E sub B, ito yung estimated error na na-attain upon measuring quantity B. Meron tayong E sub C, ito yung error, again, na na-attain natin upon measuring C. Okay? So, si Z naman, this is the computed quantities from the observed quantities. So, for example, si A and B are the length and the width. Therefore, if we're going to compute the area, yung Z natin is the area. Okay? Function sa, ang definition kanina, diba? This is the function of an error of the measured quantity. So, the formula now becomes this one. So, Z is equal to the function of your independent observed quantity, which is your A, B, C, D, and so on. Okay, so pag you take the function, this will become, this is a partial derivative. So easy, this is the error attained in computing Z. For example, nag-compute tayo ng area. So, ano yung error sa area? This is E sub Z. So, plus minus the square root of the partial derivative of f, function ng f over the partial derivative of a, times the error na kukumit natin sa a squared. So, this is the same all throughout. So, ito yung mangyayaring concept ni error propagation. So, I have here some of the types of the error propagation and how are we going to identify this error, these errors. Okay? So, have here, let's start with the error in a sum. So, this is a square root of the sum of each individual measurements squared. So, it is used when there are several measurements with differing standard error. Again, it is used when there are several measurements with differing standard error. For example, this is muna is the formula. So, the formula in computing the error in a sum is just the square root of your plus minus the square root of individual errors in different observation. So, for example, nagme-measure tayo ng if we measure a 1,000 meter na distance, so, pag at unang bisection natin siya na measure, so, first section, yung error nakuha natin is 0.1. Sa second section, nakaka-error tayo ng 0.2. And sa third section, until na-complete natin yung distance na 1,000 meter, so, this is just a square root of the error attained in section 1, the error attained in measuring section 2, and the error attained in section 3. So, they just take the square root. So, I have here some of the example. So, where yung E, that is the estimated error in observed quantities. Itong mga E na to. So, these are estimated error ng observed quantities. So, if these are sum, so if you take the sum of each individual measurement, so makukuha din natin yung error ng sum. So, I have here some I have here a situational problem which we can apply this error in a sum. Okay? So, assume that a line is observed in 3 sections with the individual parts 2. We have here, ang unang parts is 753.81. Yung error niya upon measuring 753.81 is plus minus 012. The next section is 1238.40, and the error niya in measuring this distance is 0.028. The third one is 1062.95. Yung error niya in computing this is distance, or in observing this distance, is 0.02 feet. So determine the line's total length and the anticipated standard deviation. When say line's total length, yung sum ng whole, the sum of the whole length of the line that is being measured. So which is sum. So we are going to use the formula error in the sum. So the solution, we're going to use this formula. And we take the sum. This is the error for the first section, error for the second section, and the error of the third section. So this is direct substitution to the formula. Therefore, the error of the sum, or the error of the length, total length observed na measure is plus minus 0.036 feet. Okay? So can you please check my solution if this is correct? So therefore, so the length of the line is equals to 3055. You just add the sum of the line plus minus 0.036 feet. So this is the correct uh, answers if you are going to determine the length of the line with the corresponding standard deviation or standard error upon measuring the whole length of the line. Okay, so I hope this error of the sum is clear. So the next one is, you have here, so this one is the error in the series. So the error in the series is equal to each measurement times the square root of the number of measurement in a series. So this is described as the error of multiple measurement. So maraming beses mo siya measure with identical standard deviation, which means, for example, yung 1,000 meter, ginamitan mo siya ng 100 meter na tape to measure. Bali, yung 100 meter na tape, 10 times mo siya ginamit to measure that 1,000 meter. What if that yung tape na 100 meter, may error siya na 0.20? So, which means, yung 0.20, 10 beses mo siya ginamit. So, yung identical yung standard deviation, hindi siya nag-change all throughout. So, 0.20, 0.20, that is 0.20 times 10. Okay? So, the formula for the error in series is error in series plus minus E, that is the error in individual measurement, which is identical naman, so that is E lang, square root of N. So, bakit daw hindi natin pwedeng igsasum lang yung 0.02 na error times the number of observation? So, the answer is, kailangan siya naging square root because we are dealing with the positive and negative values. So, pwede lang sanang 0.02 plus 0.02 plus 0.02, diba? Para maging error of the sum. But we are dealing with the positive and negative values, and multiple individual measurement naman with identical standard deviation, so we can use this formula. So, error in the series. So, plus minus E, the square root of N, where yung ating N is the number of observations. So, ilang beses natin nagamit yung 100 meter tape para ma-measure yung 1,000 meter na distance. So, in this example, so measuring a 100 meter line with with the tape of 100 meter long. So, yung 100 meter na 1,000 meter na line, yung 1 kilometer, ginamitan natin siya ng 100 meter na tape lang. So, 1,000 divided by 10. So, 10 beses natin ginamit yung ating 100 meter na tape. Okay? So, we have also we have a sample problem in this error in the series. So we have here, assume that any distance of 100 feet can be taped with an error of plus minus 0.02 feet if certain techniques are employed. Determine the error in taping of a 5,000 feet using these skills. So, yung concept is, ano yung a-attain natin na error if yung gagamitin na tape natin to measure a 5,000 feet is 100 feet plus minus 0.02 na tape. So, gamitin lang natin yung error of the series na formula, which is this one. So, yung ating 500, error of the 500 feet. So, this is equals to plus minus 0.02. Yung n natin is the number of observation. So, ilang beses ba natin ginamit yung 100 feet na tape in measuring 5,000 feet? So, that is n. So, what is the answer in the error of the series? Yes. If we compute this one, can you check my solution? So, plus minus 0.14. So, this is now the error attained in measuring 5,000 feet using 100 plus minus 0.2 na tape. Okay? So, if the standard is, if we say that the standard is plus minus 0.10 feet, then, itong measurement na to is hindi siya acceptable. Because, naglagpas na siya sa 0.10. So, 0.40 na. So, pwedeng hindi i-accept yung ganitong klaseng data. Okay? So, another example. So, this is another example. So, we have here, a distance of 1,000 feet is to be taped with an error of not more than 0.01 feet. So, determine how accurately each 100 feet length must be observed to ensure that the error will not exceed the permissible limit. So, the same lang siya, error in series, but the concept of the problem is the same. Ito kasi, meron siyang given meron siyang limitation. Dapat daw, pag nagme-measure tayo ng 100 feet na 100 feet na distance, dapat yung ma-accumulate natin na total error, dapat hindi siya maglagpas ng 0.10. Ito, this here. This one. So, upon measuring 100 feet, ano dapat lang yung ating error per 100 feet? So, ito yung ating sasagutin. So, if we're going to solve this one, again, we're going to use the error plus minus the error observation in the square root of the n. We have here the formula. So, the given will be yung ating error ng series, or which means yung error ng ating 100 feet na line, which is equivalent to plus minus 0.10. So, ito yung magiging target natin na limit. So, n equals to 100 feet over 1,000 feet divided by 10, which is equals to 10 observation naman, which is n. So, our required is the error to be attained in every 100 feet na tape ng length, na tape ng gagamitin. So, with now the error. So, the solution would be this one. We substitute the formulas. The error of your 1,000 is equals to plus minus of the required, which is the E, and times the square root of n. So, we substitute the values. This is 0.10 feet equals to the error. So, if we divide both sides by the square root of n, so your E becomes plus minus 0.0316. So, this would be the maximum amount of error in your 100 feet. Because if we change that values to 0.04, hindi na natin mamimit yung 0.1 na error in the series of 1,000 feet. So, if you try to check, you substitute that value 0.04, yung magiging answer ni error ni series is not anymore 0.10. So, yung survey, hindi na magiging acceptable. So, you have to redo the survey. Okay? So, this is the error in the series. So, next we have for Uh, Error in redundant measurement. So for the redundant, so it is a measurement is repeated multiple times. For example, yung angle. So repetition na. So if you measure one angle, tapos 10 times mo siya, so repeat lang, nire-repeat lang yung pag-observe ng angle in one instant of observation. So the format to be used is the error in redundant measurement. So the formula for this one is equals to the error of redundant measurement equals to plus minus the error attained in the redundant measurement and over the square root of n, which is the number of observation. Okay, similar. So next one we have here. So the error of the product. So this is common on the elementary surveying. Na-introduce ko na hiniya iyo. So the error of the product is just the plus minus square root of the A, which is the first independent measurement na gagawin mo, squared. We have the error of the B, yung second, error ng second of independent measurement. You have the B, which is your second independent measurement, and EA is the error of the first independent measurement. So, parang nag-i-exchange lang siya ng values. So, where your A is the independent measurement, B, second independent measurement, and your EA and EB is the estimated error in observing your independent measurement A and B. So, I have your sample problem. So we have here, for the rectangular lot given in the figure, as you can see, so observations of sides A and B with their 95% error, meron silang error na 95% of 0.053 for the length and 0.0672 for the width or to length. So, calculate the parcel area and the expected 95% error in the area. So, ito yung example kanina natin. So, the rectangular lot. So, however, if we're going to measure the length of the line, meron siyang error, and the width of the line, meron din siyang error. So, we are going to calculate the area, magkakaroon din siya ng error in the area. So, we are going to use the formula na kanina ipakita ko. So, here the solution. So, the solution of the problem. So, error of the product. So, we're going to use the formula where given natin sa A, measurement ni A, which is 252. So, ang error ni EA is this one. For the B, length ni B, and the error of B. So, we are going just to substitute the values. So, you can compute na the area. So I don't have here the answer. So kindly solve the answer for this. And compute also the area of the parcel. And plus, you have here plus, minus the error of the product. So you can solve on your own of what will be the answer of this problem. So next we have here, so very easy lang ang the error of the product only if there are only two variables or two independent variables. What if we employ three or more independent variable? For example, nagko-compute tayo ng volume. Si volume, we use the length, the width, and the height of a certain three-dimensional objects. So, another one is we are dealing with the trigonometric leveling. So, nag-employ tayo ng mga trigonometric function. So, more than two variables. So, I have here another example and to show you how can we solve a problems dealing with more than two or three variables. So this example of error involving more than two independent measurements. So we are going to employ now the partial differentiation. So we have here the sample. So the dimension of the rectangular tank. So nakikita nyo yung in the drawing. Shown in the figure are measured as follows. Meron siyang length na 40, meron siyang width na 20, meron siyang height na 15. So, find the tank's volume. So, ang required natin is the volume and the standard deviation in the volume. So, pamimili ko na to ang V and error in V or error sa V. So, using the measurement. So, ito yung error in measuring the length. Ito yung error in measuring the width. Ito yung error in measuring the height. So, yung error in the product, hindi natin siya pwede i-employ because we are dealing with three independent measurement. So, in this problem, we're going to employ partial differentiation. Okay? So, if we go back to the concept ng error propagation, so we have the z. Z is equals to f as a function of the a, b, and c, and so on. So, yung a, b, and c, ito yung individual measurement. So, in the problem, yung a, b, and c, ito yung length, width, and the height. So, as a function of z, so yung magiging f natin, that is the volume of the rectangular tank. So, if we follow this concept, which is the error of the z, or the error of the volume, is equals to plus minus the square root of the derivative of f with respect to the differential of a times the error in a, and the same goes with the other independent observation. So, pag sinubstitute natin sa the problem in which volume yung kailangan natin determine yung standard deviation, so this one will become this one. So, with the function of f, of v, which is the volume, with respect to the L, yung length, times the error ng length. So, second, ito rin, this is the derivative of v with respect to the w, which is the width, times the error of the width, and also same goes with the height of the tank. So, where yung ating volume, this is just length times width times height. We can compute na the volume. So, in this main formula, dito to tayo kukuha ng the differentiation. So, we are going to differentiate your V with respect to L. So, magiging constant. These are constant value. So, tatanggalin natin si L. So, yung the remaining of V with respect to L is WH. So, another naman, if V with respect to W, if we differentiate this one, so the remaining will be LH, so HL or LH. Next, we take the partial derivative of V with respect to H. So, matatanggal natin si H, so the remaining will be length times width na lang. Diba? Again, review your differentiation. So, same goes, substitute natin siya doon sa ating function. Okay? So, this is now the main formula. So, EV plus minus yung ating V with respect to L times EL. The differentiation of V with respect to W and with respect to H. So, again, we all know that the differential of V with respect to L is equivalent to WH. This one is equivalent to HL. If you take the derivative, this one also is equivalent to the LW. So, we substitute the formula W times H, which is, ito-check nyo lang ang given na value. So, the answer is 300. 40 times, I guess this is 30 times 20, which is this one. Check the value of the problem. We're L. This one also. Ln times width. And we have here EH, which is 0.02. EW, error in the width, which is given 0.03. Error in the length, which is 0.05. So, substitute the value. So, the answer would be plus minus 28 feet. So, as you can see, as you observe in this data, sobrang laki ng sobrang laki ng second term. It could be compared this with 225 and 256. Sobrang laki ng 324, which means, pag measure ng error of the W, di ba? Error ng W, second term. So, the next time we measure error of the W, kailangan i-minimize yung kanyang error because it can greatly affect the amount of the error. So, sobrang laki niya. So, as you imagine, yung atin lang error is 0.3, 0.2. and 0.5 in measuring the length, the width, and the height. If we're going now to determine the error in the volume, so this is very big na, maski sobrang liit lang ng error na na-commit natin o yung estimated error natin in measuring the individual measurement. So, if we determine na the volume, it now becomes so large error. So, plus minus 28 feet, that is too big na compared to the other individual measurements. So, therefore, your final expression is equivalent to uh, 12,000 plus minus 20. Where did I get the 12,000? That is the length times width times height plus minus your 28 feet. So, usually, itong 28 feet na error is sobrang laki na for this type of survey na sobrang liit lang ng distance between the length, height, and the width. So, for this example, kung yung limit lang na i-accept is plus minus 10 feet o plus minus 5 feet, so hindi pasado yung ganitong survey, which means na aabot na siya ng 28 feet yung error. Okay? But, in the cases na accepted lang kahit plus minus 30 feet lang yung error, then this one is accepted. Okay? So, the rest, I have some of the sample problems. This is, computation is found on the PDF that was given to you. So, some of the sample problems also are found on that book. So, you try to solve those problems. I have here also sample problems. So, I have here sample exercises. So, these are given on the activities. Last time it was sent in your email, so I hope you will answer this. Just follow the concept of the errors in propagation. Okay, so this will be the end of this presentation for the error in propagation. I hope you get something out of this. So this is very essential, especially in conducting a survey. So kung nami-meet ba nato ang standards or nami-meet ba nato ang limit, di ba? Because in every observation there always an error, but we must limit the error to meet the standards. Okay? So see you on the next topic. Thank you for your time.